Okay, so I think we can start now. So we are going to discuss today key features in Spark 3.x. So my name is Bhavuk Chawla, and I'm founder of DataCouch. I'm Google certified ML engineer and Google certified data engineer. Also done a lot of certifications related to Spark, and I worked in various projects in Spark. So I would be sharing knowledge related to Spark 3.x today. So it will be great, like if you can ask questions on the chat and if you can participate with me, then it will be great. So let's get started. So the agenda for today is like we will be looking into the key features of Spark 3.x. And after that, we will be discussing about the partition pruning concept. And we will see different types of partition pruning that we have. So we have static partition pruning, dynamic partition pruning. And after that, we will be looking into adaptive query execution. And then we will also be delving deeper into the areas that we are discussing today, primarily like dynamic partition pruning and adaptive query execution, even though there are so many new features which are released, which are part of Spark 3.x. But we would be focusing on two main features through which we will see the hands-on also on the Databricks platform. So we will look into that today. Yeah. So this is about me. I have more than 16 years of experience and working in various technologies. So I just talked about myself, and I would highly encourage you to connect with me on LinkedIn. So this is the QR code through which you can connect with me on LinkedIn. And this is about the company DataCouch, and we are into various areas, including big data, machine learning, artificial intelligence, and many other areas like DevOps. So now we have been doing a lot of knowledge sharing sessions for various companies, including Starbucks Coffee, Seattle, Google Singapore office, as well as Microsoft, and a lot of other companies. So we have been doing sessions for a lot of companies, a lot of enterprises. So we have trained more than 20,000 participants in person as well as online trainings. And we have delivered a lot of sessions across globe. So this summarizes the workshops that we have conducted. So if you're not speaking, can you be on mute? Yeah. So Deepak, if you're not speaking, you can mute yourself. You are still unmuted, so I'm just checking. I will request you to put me, see if I can mute you. Okay. So okay, so we are like having like a lot of like, as I mentioned, like we are having a lot of clients across globe. So we have been doing it for a long time now. Okay, great. So we will first look into the features that Spark 3.x has added. So let's go to the Spark 3.x release. And I think this is the best place to start this discussion. And Spark release 3.0, which is the very first release of 3.x, because we are discussing 3.x. So we can actually focus on 3.0 specifically. And here you can see like this was released and it is now almost a year. So 10th June 2020 it was released, and during that time, like it's almost like 10th anniversary of Spark. So there were a lot of features which were added into this release, and whenever you are looking for the features which are added in a specific release of Spark, you can always go to this page, and here you can find the Jira tickets which have been resolved. So here you will find these tickets, like these are Jira tickets which are already like resolved with each release. So right now we are talking about Spark 3.0, and in Spark 3.0 there were a lot of things which were introduced. So we will be talking about the key features. So that's why the name of the webinar is key features. So we will be looking into that. But on a high level perspective, you can understand like Spark 3.0, there are features related to performance which have been added into Spark 3.0. So we will talk about couple of performance related features in detail. And then there were other things added into this Spark 3.0 release, like there is a project Hydrogen. So this project Hydrogen was announced in Spark Summit 2018. So during this announcement, it was basically discussed like how Spark can make use of GPUs, and now Spark is having accelerator aware scheduler. So this is one Jira ticket. And then we have adaptive query execution. We have dynamic partition pruning. These are performance optimization related features of Spark 3.0. So we will be delving deeper into these two features today. Apart from that, there are other things which have been added. For example, the UDF API for Pandas UDF API with type hints. These have been redesigned, and structured streaming user interface has been added. Apart from that, there are other interesting things like built-in data sources. There have been a lot of changes, like for example, Parquet ORC nested column pruning has been added. CSV filter pushdown has been added, and then nested column filter pushdown. So in case you are coming from Spark background, then you would be able to understand. Like, yeah, you're unmuted, so I'm just checking with you. Okay, great. So apart from this, like you will also see Spark has started supporting Java 8, sorry, Java 11 and Hadoop 3, and it has better support for NSI SQL compatibility. So these are like high-level points which are mentioned here, but we will definitely go into the notebooks, and we will look into the hands-on, and we will look into the code, and we will also see some whiteboarding in this session. So this is the summary of the so many Jira tickets that have been resolved. So it's not like it is covering each and every minute level detail. That's why the topic is key features in Spark 3.x. So like built-in data sources, for example, as I mentioned earlier, Parquet ORC nested column pruning, CSV filter pushdown, Parquet nested column filter pushdown, right? So these things have been added through this. Now, adaptive query execution, I will be discussing in detail. Dynamic partition pruning, these are for performance optimization. So Spark queries can run faster with these improvements. And then SQL hints have been added. So now you can give hints like you want sort merge join, or maybe shuffle has joined. So you can actually give hints to the query. That is another thing. And then GPU aware scheduling that I just mentioned about project Hydrogen. Like here, Spark can leverage GPUs, and then these are other things like Pandas UDFs and new structured streaming user interface, which helps us to monitor our structured streaming jobs in a very nice manner. And then explain command, it has been formatted for more readability point of view. So let's delve deeper into some of these areas. But overall, these are high-level improvements. You will see, like primarily, these are related to performance optimization. These are related to the data sources that we have in Spark. So those have been improved, like predicate pushdown and nested column pruning and all those things. And then support for Pandas UDFs enhancements are there, and then SQL compatibility. And then there is like extensibility of the ecosystem overall. If you see, Hadoop 3 support has been added, JDK 11 support has been added, and then monitoring and debugging through Spark is now much more easier because we have Spark streaming user interface, and then there are some additional enhancements which have been made into Spark 3, which are related to the matrices that have been added. So this is the high-level idea, but let's see what exactly like we are talking about. First, we will see the compatibility. So as I mentioned, JDK 11 support is there, and then data source version 2 API support is there, and Hadoop 3 support, Python 3 support. So Python 2 is completely deprecated. If you go back to the list, and you will see, if you go down further, you will see like Python 2 is deprecated and the Jira ticket is resolved. You can see Java 11 support, Hadoop 3 support. And here, if you just search for Python 2, you will find Python 2 is completely deprecated. So you can easily find it here. Yeah, Python 2 support is deprecated. Yeah. So this is a high-level idea. So let's delve deeper into a couple of these areas that will add value to this session. So first of all, I will talk about the partition pruning, and we will start looking into the details of the partition pruning. So when we say partition pruning, very first thing is like it is an optimization technique. So it is helping our queries to run faster, and it is helping us to avoid doing full table scan. So you know what is the best way to process big data? Best way to process big data is don't even read it. So this is a principle that has been followed. So if you want to process your big data fast, then don't even read it from the disk, right? So you can actually skip the data. If your catalyst optimizer, if the optimizer which is working behind the scenes, like under the hood, the queries that optimizer can skip the full table scan, then it is going to benefit the Spark processing, because Spark is not even reading that data from the source, right? So that's the benefit. So it avoids the full table scan, and it is applied on columns which are having like limited number of distinct values. For example, the cardinality is low. So let's say we have a column called state, and state, we know that in United States, maybe number of states are 50. Let's assume that, right? So we have customers from different parts of United States, and the total number of states are 50. So we can say that we have a table, and in this table we are representing that table as a directory here. So we have a table customers, and within that table we have various customers, like these are in the form of like records in various files. So this is a directory. So you can understand, like this is a directory, and this directory is there on some storage, right? So it can be HDFS or it can be anywhere. Like this is a directory, and this directory has data for various customers. So in this case, what is happening, like when I fire a query, let's say when we fire a query, select star from this customers, and we are looking for state equals to New York. So let's say we have data like this, and we are firing a query, select star from customers. So we are saying where state equals to New York. So I'm representing directory as a table, because in Hive, if you know, like, or in Spark SQL also, you will see like we can map a directory to a table. So this is a directory and this is a table, and this table we are firing query, and it will go into the storage layer, and it will start reading data from the storage layer. The problem with this approach is, if you see the problem with this approach is, it will perform full table scan. It will perform full table scan. So that means it will read each and every record in this data set, and it will compare the state is New York or not, right? So it will compare the state value, and state values are here. So this will take long time. This is like time consuming. So that's why we have the static partition pruning, and it is not part of Spark 3. Like it is there since like long time. It's not like introduced in Spark 3, but we need to know the background of partition pruning before we actually talk about dynamic partition pruning. So that's why we are discussing this. Like partition pruning is basically optimization techniques, and techniques, one of the optimization techniques, and it avoids full table scan, and it is applied on the columns which are having limited number of distinct values, low cardinality, for example, state column that we are discussing. And then predicates or the where clause we are having, we have like a column matching the partition column. So what we are looking into right now is static partition pruning, and we are saying that the data which is organized here is not optimized, because here data will be scanned first from the data source, and then it will be filtered. The filtering will be applied on the entire data set. It is not optimized. So Spark is doing filtering, and Spark is like reading data from the source. So it is like working, entire data set will be iterated, or you can say Spark is working on the entire data set, and it is full table scan. It is not optimized. So that's why static partition pruning was introduced before Spark 3.x. Like, so that is how we used to do it. So the solution to this problem is we partition our table by a column or maybe multiple columns. So right now we are talking about state column. So our predicate is state. So we are partitioning our data based on state column, and we are reorganizing our data. So this is a new table, and this table is having state equals to New York, state equals to New Jersey, state equals to CA. So we are having like various states, and within that we have various customers of that particular state, right? So when we apply this partition pruning, so then you can say filtering is happening. So we are able to avoid full table scan here. So then scanning of data will happen only for state equals to New York. It will not be doing full table scan, right? So that's the benefit that we are getting, because we are avoiding a lot of disk IO and network IO. So we are able to optimize it, and we are able to scan less amount of data and filter. We are filtering before we read. So we are basically following the principle that best way to process big data is don't even read it. So we are not even reading the big data from the source, right? So that's the benefit here. So I hope you are clear with static partition pruning. That's how we used to do it before Spark 3.x. And right now also, this is a very common technique. It is existing since long time, but Spark 3.x. Yeah, if you're not speaking, you can mute yourself. If you're not speaking, you can mute yourself. Yeah, thank you. So you can see like in partition pruning. So I hope the concept of partition pruning is clear, that we want to avoid full table scan. We want to read less amount of data. So that's the concept of partition pruning. Now, there are two types of static like partition pruning. One is static partition pruning, and second one is dynamic partition pruning. Static partition pruning, you will see partition filters are determined during the query optimization time. So we have just seen that example also, like static is there before, it is there since long time, and then dynamic is there introduced in, this is introduced in Spark 3.x, 3.0 specifically, but I'm writing 3.x. So in dynamic, the partition filters are determined at the query runtime. So we will look into that, no need to worry, and it is enabled by default. So let's move into dynamic partition pruning. But before I move into dynamic partition pruning, do you have any questions on static partition pruning?
So Bhavuk, you told that cardinality should be low. So is it relative to any, you can say database count, you can say the
Very
total
good.
number of codes, or maybe just irrespective, or maybe it should be less than 100 or something kind of that?
Very good. So when I say cardinality should be low, that means like it should not cause small file problem, right? So if you are having high cardinality, let's say you are building a partition on primary key. If you do that, then what will happen? You will have very, very small files in each partition, in each folder. You can expect like because you are doing it on a unique key, or maybe first name, or because they are also like having high cardinality, like first name, because there are like a lot of people having the same name in US, like Tom, Alice, yeah, Harry. So you see, then like here sorry, then you just need to see like the cardinality. When I say cardinality should be low, that means like we are targeting a cardinality of 50 or 100, but at the same time, you need to ensure that the files within that partition are not causing small file problem, right? So if they are too small, then instead of improving the performance, it will bring down the performance of your query. So this is the intention. This is the criteria that we usually keep when we create partitions. But in case you have you want to optimize based, there is another technique which is called bucketing. So in bucketing, we choose a particular column which is having high cardinality. But right now we are not talking about bucketing. If you want to discuss this more, we can discuss once we are done with Spark 3.x features, then we can discuss about bucketing more. But right now, I'm just thinking aloud. When you are choosing a partition column, so usually those columns are picked up, which are very commonly used in the where clause. And we ensure that we are not causing the small file problem in our data source, because HDFS and many other data sources, you will find small files, they create a lot of issues. So disk seek time should not be like more than disk read or write time. So there are many other reasons for saying so. So does it help, Diptansh, like how do we decide which columns are good candidates?
Yeah, it helps.
Okay, great. So I
Thank you.
hope this is fine now, no problem. So I'm just moving on, and we are moving to dynamic partition pruning. So Spark 3.x actually introduced a concept of dynamic partition pruning. And here we are talking about fact table and dimension table. So very first thing is like, what is a fact table and what is a dimension table? So this is a common term that we use in a lot of when we build our schemas like star schema, and when we do data modeling, then you will see like fact table, dimension table. These are commonly used terms. In case you are not coming from that background, you can simply understand like fact table is having like it's a denormalized structure right now, and you can see like the fact table is having employee ID, department ID, and salary. Maybe these two IDs we are linking, and then we are specifying this maybe in this is like in thousand USD is a unit. So this is just numbers. These are just numbers that we have specified, and then we have a dimension table. So dimension table is like a master data, you can say, for the time being. And then we have fact table. So this fact table is very, very large. This is like a very large table. This is a very large table. And this is like comparatively a smaller table, very small table, or very smaller table. Right. So this is dimension table. This is fact table. And we have kept it simple right now. So we have not shown a lot of dimension tables here. But here you can understand this is like fact table, and we want to join with our dimension tables. So in dynamic partition pruning, let's say we have a query, select star from employee and department. This is a common thing that we do when we are doing analysis. So we are joining the data sets. So we are joining the employee table, and we are joining the department table. So this is the employee table, and this is the department table. So we are joining these two tables together, and we are saying where manager ID is true. And these are like the join conditions that we are specifying. The common key is department ID. So this is the department ID, and here also we have the department ID. So when we are joining, then we are also specifying manager ID 2. So manager ID 2 is this one. So we know that for this particular manager, this is a marketing department. And there is one more thing, like this fact table is actually partitioned by department ID. So in this case, our data, this is our large table. This is like our big table, and it is having lot of data, and it is partitioned by department ID. But can you see like here, when we are firing this query, we are not using department ID in the where clause. So you can clearly see that this will not be using any static partition pruning. So if you see in this case, the problem is the where clause is not having like specific department that we are looking for. So it will not leverage, it will not by default, without partition pruning, by default, that means without partition pruning I'm writing, because by default dynamic partition pruning is enabled. So without dynamic partition pruning, so then what will happen? It will not leverage, it will not leverage the partitions that we have in employee table. Because in employee table, the partitions are based on department ID. But we are firing queries based on like some other attribute, right? Now, that's the problem, and how it is basically troubling us, because here the filter is being applied here. And let's say the filter here is, MGR ID equals to 2. And after doing filtering, we are left with like only one department. So department ID, because if you go back, you will see manager ID 2. We are left with only one row. So we are left with department ID 2, because after filtering, only this department is left. Only this department is left, right? But here we are scanning the entire data set. So the problem, are we clear with the problem? The problem is the filtering is happening on some other attribute, which is not basically exactly the partition ID or this partition by ID or partition by column. And we are not able to leverage the partitioning that has been done on the fact table. So in order to solve this problem, if you are not very clear with the problem, I will repeat. So I'm just sharing with you, like we are having a scenario in which we have a very large fact table. And when we have dimension table, we are joining these two tables together based on common department ID. And this fact table is already partitioned by, this is partitioned by department ID. So this is the current scenario. So in order to leverage the partitioning of fact table, we should basically use something related to department ID. Then only the partition pruning can be done. But right now in our where clause, we don't have department ID as such, like specific departments that we are looking for. In our where clause, we are having manager ID. So which does not basically map directly to the the static partition pruning that we were discussing earlier. So then what we have to do is, like, we have a new concept in Spark, which is dynamic partition tuning. What it will do, it will intelligently first understand, like we are looking for department 2 because after applying the filter, we got it, like how which all partitions we are looking for. And then in dynamic partition tuning, it will push these details. It will push these details. If you see, it will push these details here. And I'm just writing here. So it is pushing the dynamic partition pruning details to fact table, which is already partitioned by department ID to. So this is pushing the department ID to this, so that when we read data, when the Catalyst optimizer will read data from the fact table, then it will apply the filter. So that filtering based on department ID can be performed on the fact table, and we can leverage the partition concept. Are we clear with this thing? I see someone is joined. Okay, so I think now any questions till now? Okay, got it. Chaitanya, great. So I'm just repeating once more, like in dynamic partition pruning, the benefit that we are getting is the actual department IDs that we are interested in. The Catalyst optimizer will push that to the fact table so that the filtering can be applied here, and then the data size can be reduced. Otherwise, if you use static partition pruning, then it will not help, right? Because here the manager ID is not the partition and not the partition column. So it is something else, like some other attribute, right? Okay, so now if you're clear with this concept, so let's go to the hands-on. So let's go to the hands-on and let's see. So I am here in the notebook, and I will attach a cluster here. So let's run this thing. So I'm launching a cluster in Databricks notebook. So in Databricks, you can actually create your own account. You can go to community.cloud.databricks.com, and here you can attach a cluster. So it is still running. So it is waiting for the cluster to start, and it will start the cluster. And once cluster is up and running, then you will see there will be a green icon which will be displayed here. So I'm waiting for the cluster to start. So in the meantime, I will give you walkthrough of this notebook. So we are saying that dynamic partition pruning enabled to true. We are explicitly writing, but by default also it is true. So just to show you the property which is applicable here. And then we are first dropping the employee table in case if it exists, then we drop the table, because you are running that cell multiple times, then it should not cause problems. And after that, we are creating an employee table. We are inserting data into employee table. We are selecting from the employee table. So these are the steps which are involved here. And after that, you will see a similar kind of scenario that I was discussing on the whiteboard. So this employee ID, department ID, salary. So these things are here, right? So it is still waiting for it. It will take, I think, 2 minutes. So I will go to the clusters and I will just see, like it is pending state right now, and the cluster is getting created. So once it is created, then we'll get that response here. So I'm going back to the dynamic partition pruning. So I hope this is clear, like the same kind of fact table. So this is a fact table. And this fact table is having employee ID, department ID, and salary. And we are also having, Shiva, if you're not speaking, you can mute yourself. Let me see. Okay. After that, we will also see we have the department, and this department is like fact, like our dimension table. And in this dimension table, we have the manager ID and like this name and department ID. And then we are joining these two things together. So, so this is getting joined here. And in the join, you can see we have the same query that I was writing there. So manager ID is 2 on the whiteboard. And then we will also look into the plan. So when you look into the plan, so I have the execution already done on the notebook. So it is taking some time to create the cluster right now, but usually it is up and running in 2-3 minutes, but I will not waste your time. So I will quickly show you specifically the things that I wanted to show. Can someone share like where the dynamic partition pruning is happening? Like since you are looking at the plan of the Spark Catalyst Optimizer, if you can someone highlight, because you can see the plan right now. So can someone confirm that if dynamic partition pruning is working here or not in the plan? So I just want to ensure that you got the concept through the whiteboard. Yeah, Diptansh, please go ahead.
Last line where it's asking for dynamic pruning and department ID.
Very nice. So you can see like this is our employee table, and this employee table, we are having this dynamic partition pruning is being applied, and it is able to figure out which particular department we are looking for. So here it is clearly showing that it is using dynamic partition pruning, right? So it is reducing the size of data that we are reading from the fact table. So that's the benefit that we are able to achieve. So that's the optimization, and the purpose is best way to read to process big data is don't even read it. So that's the concept that is being applied, and after that we have the results. So I hope you got the concept related to dynamic partition pruning. So we can post this notebook in our blog, and then you can have a look and you can run this notebook at your own pace. So it is stuck, not sure why, but usually it is very fast. So I can otherwise create another cluster and so. But anyhow, this works very well, and we have done it like at 2 o'clock this morning, so this afternoon. So I hope this you will be able to execute it, and we can post this notebook in our blog. Okay, so this is one optimization done in Spark 3.x, right? Dynamic partition pruning. Now, there are other improvements also in Spark 3.x coming back to the list. So there are so many other improvements, built-in data sources, and then adaptive query execution. So we just discussed the static partition pruning, and static is not part of Spark 3.x, but we discussed dynamic partition pruning. We also discussed static partition pruning to clarify the concept related to dynamic partition pruning. Now I'm moving on to adaptive query execution. So in adaptive query execution, so as the name indicates, it adapts, and during query execution, so it will adapt during the query execution. So let's go there and see like what kind of benefits it is providing. So this is also performance optimization technique. Adaptive query execution is also performance optimization technique. It is not a functional thing that has been added. So it is helping us to improve the SQL, Spark SQL performance specifically, because Catalyst Optimizer is actually working on it. So very first thing, before we actually look into adaptive query execution, so we must understand, like we have a component called Catalyst Optimizer in Spark, which is basically responsible for optimizing the queries, right? So we have like in Spark we can write SQL, we can write data frames, we can write code in data frames, we can write code in data sets API. So we have various ways in which we can write code in Spark. So once you write the code, then there is unresolved logical plan. So in unresolved logical plan, it is checking the syntax, right? So it is understanding like if everything is fine or not, right? So it is looking into that aspect, like the Catalyst Optimizer. If you see, like it is having unresolved. So when I say unresolved, that means it is not able to resolve the attributes right now. It is just checking the syntax. It is just checking the syntax. It is basically ensuring that you have everything which is required for running a query successfully. So it is having like it is checking the syntax, is everything is fine. So it is just doing those kind of things here. But the next step is actually look into the logical plan using catalog. If like, Spark maintains catalog of various columns that we have. So it will resolve that logical plan, and it will have like a resolved logical plan. So this resolved logical plan will basically be looking into the catalog and data types and various other things, and then it will build some logical plan, like should we do scanning first, should we do joining, should we do filtering, so should we do aggregation. So this kind of logical plan will be there. So scan, join, so these kind of things, filter, project, aggregate, so these things you will see. Now physical plan is specifically like then you have an optimized logical plan. For example, you are filtering later on and then scanning first. So instead of that, we can basically filter first and scan later. So it will optimize, it will try to optimize it, like and then we have physical plan. And in physical plan, there are various ways to actually execute the Spark query. So it will figure out what are the various ways of executing Spark query. So it will try to combine multiple things, and it will try to find out various possibilities of executing a Spark query. So how this should be executed physically on the cluster. So when I say physical plan, so it is basically deciding the strategies, like how the execution strategy should be on the cluster, right? So it will start looking into the how to convert the optimized logical plan to the physical plan, right? So it will start adjusting the physical plan, and so that it is ready for the execution. So it will start applying the various rules and other things. So once we have the various possibilities of executing the Spark query on the cluster physical plan, then it will pick up the cost-based optimizer. So this cost-based optimizer will see what is the cost involved when we run a physical plan on the Spark cluster. So it will pick up the Spark query which is having the least cost involved, right? So cost-based optimizer was introduced in 2015, and it is basically it is like ensuring that we are taking into consideration all the table statistics. We are taking into consideration the cardinality estimates of the various columns that we have. We are also taking into consideration, like, should we go for the broadcast join, or should we go for the shuffle hash join, or should we reorder the joins? So it is taking care of all these things, like cost-based optimizer, and it is understanding based on the statistics that we have collected, right? So this is like cost-based, and then we have the selected physical plan based on the cost-based optimizer. So it will once it understands that this is the best selected physical plan, then it will convert that query into RDDs, because under the hood everything is like being executed in the form of RDDs API. So this is the background. If you are not very clear with the Catalyst optimizer how it works, please feel free to ask if you are not very clear with any of the steps that I just discussed. But if you are okay, then I will talk about the adaptive query execution, like how it is helping.
So hi Babu, Harshit
Yeah,
this
yeah.
side. So
Yeah, please.
this entire process, like the entire blocks, like we can see, right? The unresolved logical plan up to till the RDDs. This entirely called as catalyst optimizer, or only that. I mean, how some of the blocks are comes under the catalyst optimizer.
Actually, Catalyst optimizer is having multiple phases. So so Catalyst optimizer, when it is working, then it is taking your query through various steps. So that's like step-by-step execution that Catalyst optimizer is doing. So overall, when you see like explain plan. So what is explain plan? I'm not sure if you have seen, since I'm assuming you have worked with Spark, and when you do explain on any like DF or maybe any query, so when like SQL query, and then you write explain, and then you write extended equals to true. So when you do that, then you can see how the optimizer, Spark optimizer, Catalyst optimizer will actually optimize our query. So you will see, it will show you when you say extended equals to true, then it will show you the parsed logical plan. It will show you the analyzed logical plan. It will show you the optimized logical plan. It will show you the physical plan. right? So it will show you a lot of details. So that means all the things are being done during the optimization phase by the catalyst optimizer. And these are the steps which are involved, like these are the sequence of steps which are involved, and it is all done by the catalyst optimizer.
Okay, so this cost-based cost model optimizer, right? That this comes under the catalyst optimizer.
Absolutely, yeah. So this can be turned off also. It's not meant like there is a property also CBO, like you can turn off this cost-based optimizer because it was introduced in 2015, and
Okay.
this was like Huawei company worked on a concept, and Spark 1.2 actually introduced cost-based optimizer, and then there was like in Spark Summit 2016. So there was a very nice discussion on cost-based optimizer. So in general, like this cost-based optimizer is a pluggable thing, right? So it's like it can be turned on, turned off, because initially you will see like a Spark, whenever a new feature is released in Spark, so you will have a property to control. So a lot of times people are not comfortable introducing new feature into their production environment. So they can actually upgrade Spark, but then they can turn off the specific features that they think are still getting stabilized. But right now it is very much stable because it is like there since 2015, and Spark 1.2 itself introduced cost-based optimizer. For this particular release, like Spark 3, you can safely use it, and by default it is enabled also, so no problem. So
Yeah,
that's the
okay.
idea. And does it?
Okay.
Yeah.
Yeah, got it. Thank
Okay,
you.
great. No problem. So I hope you are clear what is cost-based optimizer and how it is helping. So it is basically looking into the table statistics, column statistics. It is understanding like the cardinality. It is understanding min-max values of each column. It is understanding the null count. It is understanding the distinct count. It is understanding the average length of the strings that you are having, or maximum length of the string. So it is understanding everything to build a plan which is basically optimized to execute on the cluster. So that's the simple introduction to cost-based optimizer. Okay. Okay, great. So if you are clear, then I will move on. Now we are talking about adaptive query execution. Till Spark 2.x, like any version that you will see, like we were not having this feature, but this is a very interesting feature which has been introduced, adaptive query execution. So what exactly it is? So in adaptive query execution, we have a very smart way of like executing this. So what is the exact smart way? So what is the adaptiveness that we have? So if you see this, like we have, let's say this is RDD and this is logical plan. So here we have feedback process, or you can say during runtime, it is giving inputs. It is giving inputs to the planner. It is giving inputs to the planner. So it is called during runtime. It is called planning is happening. During the runtime, planning is happening again, right? And what it is doing is like it is giving a feedback. So it is like adaptive in nature. So it is adaptive in nature, and it is also called adaptive planning. So during runtime, it is giving this input, the adaptive query execution, this feature in Spark 3.x. So basically, it is helping Catalyst Optimizer to optimize the workflow overall, and it is adjusting the query plans based on the runtime statistics that we find. So, the statistics of the tables are stale, because before Spark 3.x, we were relying on the statistics of the tables. And what was happening was like when a query used to execute, then the statistics of the tables were missing, or they were stale, they were out of date statistics. And the problem because of this was the plan was not the best plan, or plan was not optimized, right? So that's fine. You will see, like we were expecting. So let's say I will give you one example. Let's take one example. So let's say in Spark 3.x, before Spark 3.x, what was happening? We were having like we were having like, let's say we are joining two different data sets, and we are, let's say this is our data set 1 and this is our data set 2, and we are joining these two data sets. So this is our join, and here this is join, and this is data set 1 and this is data set 2, and this join is happening, right? So this is before Spark 3.x. And so when we have to apply join, so what it will do, it will understand like what is the estimated size. So estimated size, let's say this is 100 MB, and estimated size is 50 MB. So what is happening? So based on estimated size, Catalyst Optimizer, I am writing Catalyst Optimizer determines that sort merge join is required. This is like one type of join. Sort merge join is required. Now, this is a wrong estimate. Actually, the data in the table is now maybe around 3 MB or 5 MB. So it is very small data. Actually, the data in the table is 5 MB. So now actual data was estimated was this, but during like runtime, we got to know. So the problem I'm writing, during runtime, Spark Catalyst Optimizer now knows it is actually 5 MB or not 50 MB, right? So, but it cannot do anything right now. It cannot do anything for further optimization, right? So that's why in Spark 3.x, this is Spark 3.x, what happened? So here we have an adaptive query execution, So we get a feedback during the runtime. So in this case, it will get to know during the runtime, and it will ensure that the join is not sort merge join, but it is broadcast hash join, which is much more optimized. Are we clear with this thing? Like how this is working? Like during runtime, we get the more accurate statistics. Okay, so how the estimated size was wrong actually. So, you know, like in any technology, when you work with any technology, for example, you're working with relational databases, or you're working with Spark SQL, or you're working with any technology, you will find the optimizer keeps track of these statistics. And these statistics are usually missing because regularly the big data is growing, and big data is maybe getting modified, getting filtered. And the data that we are having, maybe that is something which is compressed. Data is columnar in nature. You will find like there are some user-defined functions which are working on the data, and they are black box for the Catalyst Optimizer. You will find like there are many cases through which Catalyst Optimizer will not even get to know unless or until we run that query. Does it help, Chaitanya? Like this is a very common problem in a lot of technologies, that the statistics of the tables are not accurate because the data has changed over a period of time, and Catalyst Optimizer is having the old values, old statistics, right? So these are
got it.
okay. Are we clear with this?
Yes.
So, okay, great. So there is a question on the YouTube. So the question is like companies with Databricks, Azure, Databricks, AWS, so on. This is what's the difference we need to see in each of these. So very first thing, like we have different distributions of Spark. So one is from Cloudera, that is there since long time now, and Databricks also providing distribution from since long time. And we have AWS also, EMR cluster is there where we are having Spark. So each of these distributions, they have like certain features, and they provide certain set of tools. So we are using Databricks here because Databricks helps us in creating the cluster without installing anything. So we have the community edition, so it is free of cost, and we are getting 6 GB cluster through this like community.cloud.databricks.com. Anyone can create the account, and you can go here and you can simply say that I want to create a cluster, and I say, let's say I'm creating a cluster demo, and I'm saying Spark 2.12 and then 3.1. So you can choose which version of Spark you are interested in. Do you need GPUs or not? It is so convenient, so simple, like this particular interface, and you are getting free 15 gigabytes of memory in the community edition, and it is like for 2 hours it will be up and running, and you can choose which availability zone you are running this cluster. So, and then you have Spark, like if you specifically want to specify some environment variables and other things, you can do that, right? So this is the cluster, and then you can say, I want to spin up the cluster. So through that you can create cluster, but right now, since one cluster is getting, it's already up running, so that's why it will not allow me to create one more cluster, but our cluster is here. So this is like one of the most convenient interfaces. So that's why we choose this option, but we can always go for EMR, but we have to pay money to the AWS because the kind of jobs that we are running, 15 gigabytes, definitely you need to go for some instance, maybe 2x large, M2 2x large or M2x large. So then you have to pay. It's not T2 micro or something small instance. So that's why I choose this. And here we are not installing. So we are not doing administration, but we are focusing directly on the features of Spark 3.x. But anyhow, whatever things that we are discussing are applicable in all the distributions because it is all open source that we are talking about, right? So, okay, great. So I hope that is fine. Like Vishwas, if you have any further questions, please feel free to ask. Okay, so now I hope everyone is clear that adaptive query execution is giving feedback to the catalyst optimizer, and it is helping us to optimize in the query and revisiting the query plan, and it is helping us to get a better results because you will see like there are statistics which are available. If you go to there is a blog, there is a blog from Database, and in that blog you will see the in that blog you will see there is like I'll figure out like there is the blog. In that blog, actually, it is given very clearly that how this adaptive query execution is helping in like improving the performance of the query. So I will show you that blog very quickly. So this was published last year on the Database website, and this blog is having details about the advantage of having adaptive query execution. So that I'm going to this TPCDS. This is a common way to evaluate the performance of the queries. So you can see like it is giving improvement in the performance, like 8x speed and 32 queries more than 1.1x speed. So this is a comparison like without adaptive query execution and with adaptive query execution. So what's the difference in the performance? So query performance improves when we use this adaptive query execution. Now I was talking about the join strategies. So actually, when we talk about dynamic, sorry, I'm doing there. So I was talking about adaptive query execution. So there are 3 benefits of adaptive query execution. So very first benefit is this is adaptive query execution. There are 3 benefits. So one is we are coalescing the shuffle partition. Second one is we are switching the join strategy. And third thing is skew joins optimization. So these are the 3 areas. So very first thing that we just discussed was related to the switching the join strategy. And here you can see earlier Spark was considering it as catalyst optimizer was considering it as sort merge join, which causes a lot of shuffling and it is not optimized. But if we go for broadcast hash join, so then we are distributing the small table across multiple executors where we have the data for the large table. Then it is like having we are avoiding shuffling here, and this is like a local join which is happening after doing broadcast. So this is one advantage of advantage of adaptive query execution. Second thing that we have is like coalescing the shuffle partitions. So very first thing that you need to understand here is when we talk about adaptive query execution, so this is shuffle partitions. So this is like reducing. If you're coming from MapReduce background, then you can understand it very easily. We are reducing the number of reducers. We are reducing number of reducers. So if you have too many partitions in the next stage, or you can say reducing the number of partitions in the next stage, partitions in the next stage. So if you have too many number of partitions in the next stage, then each of these partitions will have small data, and then when you write that to the disk, then it will create a lot of small files again. So this is not an optimized way to actually have too many small partitions. So it is always good that if Spark Catalyst Optimizer can combine these small partitions, it can coalesce, it can combine small partitions together, and it will help in actually getting a better performance from Spark job. So this is like another advantage of AQE. So we discussed one advantage, switching the join strategy. Second advantage is it is ensuring that the number of partitions in the next stage can be reduced, because during runtime you are able to get that feedback when you execute it, right? Third advantage is it is working on the skewed join optimization, because let's say we have partitions, and let's say we have a partition which is having too much data, and other parties, let's say we are joining two tables, like this is one table, let's say this table is like one table, and this is table 1, and we are joining this table with table 2, and let's say we have data, and this is okay, this one is not too much, but this one is skewed, this partition is skewed, there are a lot of data for this, and we want to join the data. So we want to join these two tables. This is a skewed data because one particular partition is having a lot of data, so it is skewed. So in this case, adaptive query execution will automatically split this partition into smaller partitions. So we will see one example in the notebook also in the code, that it will split this partition, skewed partition, automatically into smaller partitions. So how it will look like? So you can say we are talking about the skewed data. So let's say we have this data. So it will split. Let's say we have the skewed data. It will split it into small pieces. And when let's say we are joining this partition with this partition, so we are duplicating this one, and then it will be able to join very well. So in general, in distributed computing, we don't want skewness. So if you have skewness in our distributed computing, then one executor which is having that partition will be working hard, and that executor will become bottleneck, or you can say it will come in the critical path of the job execution. So we will be limited by that executor. So that's why if you can split it into multiple partitions, then the performance of the job can be improved, because we are not actually limited by the stragglers. We call it stragglers in Spark, like because they are like slowing down the overall performance of the job, right? So now I hope you got the idea, like what exactly is like reducing the, why we do it, why adaptive query execution is reducing the number of partitions, why it is optimizing the join strategy, why it is changing the why it is splitting the skewed data, skew join optimization. So if you're not very clear, please feel free to ask, but this is a summary. And if you're okay, then I will move to the code. So if you are okay, then I'm moving on to code. Yeah, Dipansh, please go ahead.
So this one is an ongoing plan, means till the whole execution is completed, or just before triggering the execution?
It is during the execution. That's why the name is adaptive query execution. And even during the execution also, we have many stages. So during that time also, you will see in the Spark plan, if I go to the notebook, now, so let's say we have this notebook, AQE, and in this notebook, we are enabling the dynamic, adaptive query execution. So I'm enabling this adaptive query execution. So this cluster is already launched. So I will just attach this cluster here, confirm, and this cluster is attached. So here we are enabling the plan. Adaptive query execution, we are enabling it. This is the syntax, or this is the configuration, so which you will enable. After that, we are also defining, after coalescing, like minimum number of partitions that we need, but usually you will not keep one. You will have, like in production jobs, you will have more number of minimum partitions. So I just talked about the coalesce feature and reducing the number of partitions in the next stage that we have. So it is about this, right? So now coming to your specific question, like if I execute this, right? So we have the data set, and we are having a Parquet data set, and actually it will take long time. If I execute it, it will take 10 minutes. Last time I already executed, so I will not be re-executing it to save time. But if you execute this notebook, you will find it is taking 10 minutes. So let's assume it took that much time. And I want to show you like specifically that you asked. So you asked about the query plan. Is it final plan, or is it like ongoing, or it will basically learn during the execution? Yes, the answer to your question is yes. The query plan, which is being shown here, it will learn during the execution. So you will see there is a attribute in the query plan. So in the attribute, you will see is final plan. So is false. So because during the execution, the Spark Catalyst Optimizer is still figuring out which is the best plan we should have. So in the query execution, you will see like there is a parameter also. So right now, if I make it bigger, you will find there is a parameter adaptive. Can you see adaptive Spark plan? And is final plan when it becomes true, right? Once it is able to figure out during the execution, it will figure out, and there will be a property is final plan. And I will show you how it is being done. So I was showing you a blog of Databricks. So there you will see this plan is final plan is false initially, and during the query execution, it will figure out the best plan. So is final, yeah. So final aggregation, final plan. So, but I have seen it many times. Let me show you. So for the timing, I will give the walkthrough. But Diptansh, are we clear? Like the answer to your question is yes. During the execution, Spark will figure out the best plan, and it is not in one go. It will be able to figure out. So it will be executing, and then it will be figuring out the best plan through like running multiple iterations. And during that time, it will have a variable is final plan, and initially it will be false. Once it is able to find out the best plan, then it will say is final plan equals to true. So that's how it will be. So if you see this notebook, Diptansh, any questions, any other questions apart from that, like how Spark is actually looking into the queries?
Nothing else.
Okay.
Means on every stage, maybe on save stage, maybe on reading stage, it will work.
Absolutely. Yes. Spark is actually working on the data, and it is based on that. It is optimizing. So you can see there is custom shuffle reader. So in your plans, you will see custom shuffle reader, and number of partitions are 1. So it is able to coalesce multiple partitions into a single partition, and it is able to combine like 431 KB of data is left. So why not we combine it into a single partition rather than having it in a multiple partition? So that's one benefit. And then if you scroll down further, we have switching the join strategy. So once you enable the adaptive query execution, you will see in this, we have like adaptive plan, and we will be able to see that it is able to do broadcast join. So this is our data set, and here we are able to get broadcast hash join, and it is using custom shuffle reader. So it will automatically figure out during the execution that the data size is actual data size based on the statistics that it is having. So it will use broadcast hash join rather than sort merge join. If you turn off that property, then you will see it is sort merge join. But if you turn on that property, then you will see it is actually leveraging that broadcast hash join, because that is much more optimized, and it will ensure that the data shuffling is less, right? So this is like adaptive Spark plan. So you will see in the plan itself that we have nodes like this. And then we were talking about optimized queue join. In the optimized queue join also, you will see there is a skewed partition, and it will split the skewed partition into multiple parts. And once it splits it, then the execution of the query will be much more faster, because Spark is automatically figuring out that one partition is too big for the join to execute fast. So it will split it into smaller parts, and then it will figure out, and it will run the join very, very fast. So that's the notebook, and this notebook is available. Like we will, I think this notebook is already available in the Databricks blog. You can easily get it from here. So the notebook which is not available on Databricks, we will post it on our blog. We have blog, and this DataCouch blog. If you go there we will post. So we will go to e-learning.datacouch blog. So we'll post that notebook here. So here we will post that notebook. Yeah. So I will come back to the discussion that we were having. So that's how we started today. So I mentioned that we have many key features in Spark 3.x. We have built-in sources, we have adaptive query execution, we have dynamic partition pruning, we have SQL hints, right? So this is another interesting feature. Like earlier, we were not able to give so many different types of hints, but now we can actually give hints to our queries. And this is a new addition to Spark 3.x, and it will also help us in getting more control over the checklist optimizers functioning, and then GPU scheduling and other things that we discussed. So please let me know if you have any questions on any of the things that we just discussed. If you're not very clear with static partition pruning, dynamic partition pruning, or adaptive query execution, do let me know. So we are planning to have another session on, maybe a session on Delta Lake. So that will happen maybe in a week, or maybe in 2 weeks. We will plan out that session immediately after this. So stay tuned for that session, Delta Lake. So any questions that you have?
Yeah, Bhavuk, I heard about, I mean, like there is a JAD ordering as well, right? So is it specific to Delta Lake? I mean, or is it is it common for? Okay.
Yeah, that is Delta Lake. So when we are covering Delta Lake, then we can talk about optimize. We can talk about Z ordering, right? So all those things, vacuum and other things will come into Delta Lake. Okay.
About just one doubt actually, is there any kind of a form wherein we can able to submit
your voice is breaking. Chaitanya, your voice is not very clear. Can you please come closer to the microphone, or you can, if you can type.
Is it now clear? Is it now clear, or shall I type?
Yeah, now I can hear you, but it's not like there is some muffling and noise in between. But I can hear you.
I'll be typing then. I'll be typing in chat.
No problem, Chaitanya. I can hear you. You can go ahead.
Yeah, is there any kind of a chart wherein we can able to provide these topics? For example, there is an optimizer called as Project Tungsten, right? I could not able to get exactly what a correct blog wherein I can able to understand how exactly now the adaptive query execution explained and dynamic partition pruning. In this way, I haven't got an exact blog. So is there any kind of a session we can plan in that way?
Yeah. So Chaitanya, these are the suggestions that we are looking for. So if you provide such suggestions, then definitely we can conduct a session on Project Tungsten, and we can have a session on Spark optimizations in which we can talk more about that particular area, or otherwise we can have a separate session on Tungsten. So definitely, if you share this kind of feedback, then definitely we can organize such meetups. So this can be another topic for one of our meetups going forward. Yeah, we can do that.
Yeah, sure. Why? Because dynamic partition pruning, I have read it was a new feature which was available in Spark 3.x, but problem is in this very clear manner, and I could not able to understand actually until going through the session.
Sure. Definitely, Chaitanya, we can have it. Like we can organize. Yeah. Thank you for the feedback. We can.
Thank you. Yeah. Thank you.
Okay. So then I think we are done for the day. Thank you so much for your time, and I will see you in one of the meetups related to Delta Lake on Spark, or Delta Lake with Spark, because these are two independent projects, but they work very well together. So we can see like how Delta Lake can work with Spark in one of the meetups, and why Delta Lake, we can discuss that. And then we will also see some internals of Delta Lake, like how it stores data internally and other things we can discuss in one of the meetups. So those people who are not familiar with our meetup group, so we have like a meetup group which is having 3,200 plus participants now. So if you go to Meetup Chandigarh and all things data, so you will find we have this meetup group, all things data. 3,200 members are there in this meetup group, and I would encourage you basically send this invite to others also, so that other people can also benefit from these knowledge sharing sessions. And Harshit, in case you want to lead any of the sessions, you are most welcome. So it's just that you can ping your number. We were not having, so we were not able to contact you.
Yeah, I'm just pinging you on the WhatsApp.
Okay, great,
Yeah.
great. Thank you, and thank you so much, Tiptansh. And please do share feedback related to these meetups on the meetup channel so that other people can also join, and also write the feedback on the LinkedIn. So that will help us a lot. Yeah.
Yeah, sure. And can we get those book IDs as well as the presentation which was using during the session
Yeah.
actually?
Sure. So we will. So it is all getting recorded and it is there on our YouTube channel. So if you don't know our YouTube channel, then you can go to YouTube and you can say /c/DataCouch. This is the channel. So here you will find like this is also live session right now.
Okay.
And you can watch the recordings for stream processing using Spark, and there are other meetups which we already taken related to KSQL DB and many other things.
Okay. Yeah. Yes. Thank you so much, Brooke. Actually, this is my first question.
Okay, great. And how did you come to know about this meetup?
LinkedIn.
Okay, got it. Thank you. Thank you for confirming. Okay, great. So then I will see you in next meetup. Thanks, Sanjay. Thanks, Tiptansh. Thank you, Chaitanya. Thanks, Rajesh. And have a nice evening. Bye-bye.